In this video, we introduce how to organize our data after we've collected it from a survey. Let's get started. So to begin, I want to introduce the concept of a frequency distribution. So when I say a frequency distribution, I'm talking about simply a table, kind of like you see on the slide here. It's a table in which you have your groups separated by what we call classes, and each class is going to have a certain number of discrete elements. Discrete means countable elements. Okay? It'll show the number of items in each class on the right side, and that will be called the frequency. Okay, so how often an item from that class appears in your data is known as the frequency of that class. Now, sometimes there will be a class that stands out, which has the highest number of items in it. And that class will be known as the modal class. And that term might sound a little bit familiar if you remember the word mode when we study mean, median, and mode in a future video. That might make more sense. It has to do with what occurs the most common. What is the most popular value or class of values? So let's head over here to an example of a frequency distribution on the slide here. So in our example of our frequency distribution, which is down here, we introduced the terminology of class width, and another word that we're going to learn is class midpoints. So what do we mean by these terms? Well, width typically is going to tell us how far apart your extremes are. So for example, when we're looking at this nice frequency distribution, our first class is 21 to 30-year-olds. Or at least, I guess these aren't ages, these are test scores, so that's even worse, right? So this is someone who scored a 21 to a 30% on a test. And then 31 to 40 is our next class, 41 to 50, and it continues following that same pattern all the way up to the last class of 91 to 100. Now, that pattern, if you will, could be described by what we say the class width, okay? The class width here can be found by simply subtracting your two consecutive classes, either the lower limits, like 31 minus 21, okay, or the upper limits, like 40 minus 30. Either way, if I subtract the two lower limits of consecutive classes, so that means one after another, or the two upper limits of consecutive classes, 40 minus 30, what are we getting here? That's right, we would be getting 10. So that's telling us now, the class width of 10 is telling us that if the first class had a lower limit of 21, the next class should have a lower limit of 10 more, or 31. And if the first class had an upper limit of 30, the next subsequent class should have an upper limit of 10 more, or 40. And you can see that that class width makes sense. Now, do you always have a class width of 10? No. Sometimes your class width will be as small as 5. Other times your class width might be in the hundreds, okay? So it depends on what your data is. If it's test scores between 0 and 100, then a class width of 10 might make sense, okay? All right, so we have some other tricks about class width that you're welcome to read in your textbook about, or you can do some more research about if you're going to take a formal statistics class, how to best calculate class width for your own frequency distribution. But most of the time, we're going to give that to you in this class. Now for class midpoints, what are we referring to and why do we care, okay? For class midpoints, what we're talking about is we want a representative of that class. So instead of thinking of all of the values, all the test scores between 21 and 30, for example, in this class, what would be a good representative for the entire class? Well, it would be the value right in the middle, okay? The midpoint should be right in the middle of that class. And so in order to find the midpoint, all I need to do for a certain class, every class has its own midpoint, is take the lowest plus the highest and divide by 2. In other words, taking the average of your upper and lower limit. Well, 21 plus 30 for the first class divided by 2 would be 51 over 2. And when I divide that in half, when I cut that in half, what do I get? 51.2. That's right, I should be getting 25.5. Now, would that be a good representative of this class? Well, it does appear to be right in the middle. So I would say yes, that would be a good representative. So why would I use that? Well, in a few moments, in a future slide, we're going to talk about some visualizations that we can make of our data. And sometimes what we'll do is we'll start with this frequency distribution and we'll turn it into some fancy bar graphs called histograms. We'll talk more about this on a future slide. So for example, I'm going to just tell you in advance that this histogram on your slide represents the special bar graph where all of the bars are touching and where each class is represented by its midpoint. So for example, if you look carefully at this nice picture here, we notice that each of the bars has a certain height. That height is your frequency, okay? And each class could be represented by its midpoint. So the first class, 21 to 30, would be represented by its midpoint of 25.5. Okay, that would be the midpoint of that bar, okay? And its height would have a frequency of 1, which in this case you can see appears to be in the right spot. It's the height of my bar. Then if I were to go on to get my next midpoint, let's use another color here, for this class of 31 to 40, notice what happens. 31 plus 40 is, that's right, 71.5. And when you divide that by 2, what do you end up getting? Yep, 35.5. So this would be 35.5. That would be the midpoint of the second bar. Okay, now notice the frequency is also 1 for that class, so that the bar actually stays the same height, okay? But when we go to our next class, which is in this case 41 to 50, what do you think the midpoint will be? You know how to do it, right? Add the lowest plus the highest, divide by 2. So 41 plus 50 is 91.5. Dividing that by 2, what do we get? 45.5, right? So 45.5 is this midpoint here, okay? And so in this case, what we're noticing is that the class midpoints are increasing by what number each time? 10. So they're always going up by 10, where 10 is your class width. So that's another shortcut. Once you've found your class midpoint for one of the classes, you can simply add the width to get each of the following class midpoints. So to finish off this histogram, I would put every single class midpoint in the center of every single bar, and then I would notice that my bars have to go up to the height of their frequency. By the way, do you see that the modal class here, the modal class in this example would be the class that has 71 as its low and 80 as its high? In other words, that's the most popular area where my test scores were, so somewhere in the 70s all the way up to and including 80. Okay, so this is an example of how we can organize some of our data, starting with the frequency distribution, which simply puts our data into certain classes, all right? We want to have typically at least 5 classes in a frequency distribution. And then we can use the frequency distribution to draw a picture like a histogram. We'll also be doing other types of nice charts in a few moments. So let's head over to our next slide and take a look at our options here. So in example 1, it says, can we construct a frequency distribution for the ages of the first 44 presidents of the United States on their inauguration day? Okay, so this is not up to the current day. So at this point in time when we did this, we're only up to the first 44 presidents, where the eldest was 69 upon inauguration. I think we've surpassed that by now. All right, so at this point, what I noticed first of all is that all of these ages of presidents, they are all listed in what we call ascending order. So they're from the smallest to the largest. That's very helpful. So this is our lowest or our youngest president, and this is our highest or our oldest president. Typically, when you're doing your homework problems, that's not the case. So you're going to want to sort your data in order to have a better idea of what's going on here, okay? So we want to sort our data first, and you can do that by hand. You could also use programs like Microsoft Excel to sort from low to high, okay? So once you have your data sorted, like I've done for you already here, to create a frequency distribution, we want to have at least 5 classes, okay? So once you know how many classes you want, from there it shouldn't be too difficult to figure out the class width, okay? But in this case, they've actually given me that class width because they've told me here that I want to start with the first class. So this was given that your first class contains the ages of 42 to 47. So right away you might think, how do I know the class width, right? What is she talking about? Well, it turns out if you go back to the last example, if you were to look at the first class, which was 21 to 30, if you start with the number 21, the lowest, and like you use your fingers if you need to add 21, 22, 23, 24, 25, all the way to 30, how many elements were in that class? Weren't there 10? There were, which happened to be your class width. So similarly, if I already have one of the classes, I already know my class width. 42, 43, 44, 45, 46, 47. It looks like my class width is 6. Now notice I did not just subtract 47 minus 42 because that would give me 5. It would not include one of the items. So you actually need to add 1 if you're going to subtract, add 1 each time, or just count using your fingers if that's helpful, okay? So there are 6 items in that class. So in this case, our class width is 6. Again, what do we mean by width? It means how many discrete elements are in that class. And there are 6 different ages, age 42 through age 47. There's 6 different ages there. Count them up with your fingers if you need to. All right, so once you know the class width is 6, couldn't we then figure out the next class? Yeah, because last time we said to find the next class lowest value, we added the class width to the previous lowest value. All right, or lowest midpoint, lowest value of the class, I should say. So in this case, 42 was our previous lower limit. That's technically the term for it I was thinking of. If you add the class width of 6, you would be at 48, wouldn't you? Now again, if you look at the prior class's highest upper limit is another way of saying it, 47, and add your class width of 6, where do you get? That's right, you get 53. And again, you can continue this. You can see that in each class there should be 6 distinct ages represented. That is our class width in this case. So 48 to 53. Feel free to pause the video and see if you can do the rest of them on your own. What are each of the classes here? Did you get 54 to 59, followed by 60 to 65, and then 66 to 71? Okay. Now notice here we actually went further than we needed to. The real requirement is that all of your data values are represented in one of those classes. And notice that our lowest value of 42 is definitely represented in that first class at the top. And our highest age here of the presidents when they were inaugurated is 69. And that is definitely represented in the last class. So as long as they're all represented somewhere in these classes, we are set. And of course, like I mentioned earlier, we usually want to have at least 5 classes in a frequency distribution. So once you've done that, that's the hardest part. So again, because they gave me the first class, I was then able to deductive reasoning here, what the class width was, and then use the class width to get to my next class. Once you've done that, the rest is simply keeping track by maybe tallying or just counting up in your head. Okay, so let me show you what I mean here. For the first class, 42 to 47, how many, or what is the frequency of ages in that class? So we have 42, 43, 46, 46, 47, and 47. There's my first class, right? How many items are in there? Looks like 1, 2, 3, 4, 5, 6. That's what I got. Feel free to pause the video and see if you can complete this frequency distribution yourself. All right, let's see how you did. For the second class, I'll pick another color like yellow here. 48 through 53. Again, I've sorted the data. That's really important. First step. If you haven't sorted the data, you would want to do that first. So now I would do 48 through 53. That looks like it goes all the way to 52 here. There are no 53-year-old presidents on Inauguration Day so far. Maybe in the future. Let's see if we can add up those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's also what I got. Great. Okay, I'm going to change that color in the chart because it looks really hard to see. So that should have been an 11 for that second class. All right, let's head over to our third class and see how you did. For your third class, you're looking at the ages 54 to 59 inclusively. So 54 continues this way. Oh, this is a big class, isn't it? Look, it continues all the way through 58. That is a lot of presidents that fell in the 50s, between 54 and 58 precisely. So when you add all those up, what did you get? Let's see if we get the same number. Easy to make a mistake. I got 17. Hopefully you did too. Remember at the end, they all should add up to what number? That's right, 44. That was the number of presidents we were talking about. All right, what about the next class? 60 to 65. Well, that would be 60 to 65 right here. And how many did you come up with? 8, that's right. And finally, the last class is 66 to 71-year-olds on Inauguration Day. And there were just 2 presidents at this time, right, as of the first 44, that fit the bill, and there were 2 of them. So when I add up here, 2 plus 8, you get 10. 10 plus 17, 27, plus 11, plus 6. Do you end up with 44? If so, you have taken care of everybody, okay? So you want to make sure that you do account for every single item in your data set. So first step, sorting. Second step, figure out classes using your class width and deduction. Third step, counting. Okay, that should be the easy part, but we do make mistakes as humans, so double check yourself. Once you have your proper frequency distribution, like we just created, you can then do other things, like calculate the class midpoints and then create a histogram or another type of organizational chart that we'll talk about in our future slide. So keep this one handy because I think we're coming back to this one in just a moment. All right, let's get to our next one here. On the next slide, I do want to talk about one mistake, and I want to see if you could spot the mistake that I found. When we're talking about histograms, that's our first type of organizational chart that we mentioned today. There's one thing that we need to notice before we make our histogram, and that is, do we have a frequency distribution that allows us to find the class midpoints? And it looks like we do in the second class, in the third class, in the fourth class, and in the fifth class. But there is one little error, and I wish I could say it was intentional, but I didn't pay attention until I made the video, okay? And so what I notice here is that this first lower limit is a 0. Why would that be problematic? Can you think about why that would be problematic? Well, we talked about something called the class width, right? What is the class width when you're looking at 11, 21, 31, 41 as your limits? Subtracting those consecutive lower limits, what are we getting here? 10, right? But what if we subtract 11 minus 0? What do we get? 11. So in reality, this should have been 1 to 10, okay? So technically that was a typo. If you use 0 to 10 in this case, you are going to have an uneven or a non-constant class width. So that is important to make that change in your notes and understand why that is, so that every class midpoint will be exactly 10 units apart, okay? So here I wanted to show you again how you could have made a histogram, a frequency histogram is another way of saying histogram, based on a frequency distribution. So if you knew that this was your table or your frequency distribution, if there are 4 students who did 1 to 10 sessions on the internet, these look like they're accessing a certain type of set, maybe a homework session, we're not sure. There are 5 students who did 11 to 20 sessions. There are 8 students who did 21 to 30 sessions. There are 9 students who did 31 to 40 sessions, and there are 4 students who did 41 to 50 of these study sessions, let's say. The very first thing I would do to create this histogram is find my class midpoints. So what would the class midpoints here be? Well, we kind of did this one earlier. You would do 1 plus 10 divided by 2. That's how you could find your first class midpoint for the class 1 to 10. 11 divided by 2 is what? Right, 5.5. So 5.5 should be our first class midpoint. And then from there, the next one should be 10 bigger. It should be 15.5. And then the next one should be 10 bigger, right? And you keep going this way, 25.5, 35.5, etc. They should be right in the middle of each class, and that would be how you would create this histogram. Notice that the heights here correspond to the frequencies, 4, 5, 8, 9, 4, and notice that all of the bars are touching. That's the criteria for a histogram. Use class midpoints to represent each class, use the height based on the frequency of your frequency distribution, and make sure that all of the bars touch. Most of the time, we go from smallest class size to largest, but there are exceptions when we go the other way, like you see below here, where they have the highest and then they go down to the lowest. You might not see it on the video, but if you look in the notes, you'll see it starts at 94 and goes down to 34. Okay. All right, so the next type of graph I want to look at here is called the frequency polygon. So that's actually the one I was just referring to below here, this one here. So what is a frequency polygon? Basically, if you start with a frequency distribution and then create frequency histogram, which is that special bar graph like we did above, the only difference here is that at the end, you want to take a point and put it at the top and in the center of every single bar. So go ahead and put a point at the top and center of every bar. So this is a different histogram, but if you have a histogram, if you've already done that part, then you're almost there, okay? Then once you have this at the center of every bar, you go up to the top of it and put your dot. It's simply what we call connect the dots. So connect the dots with line segments. So once you do this, you connect the dots. It kind of looks like what they sometimes refer to as a line graph, right? When you're talking about maybe the stock market or things that are very intense from month to month, price changes, inflation, different things like this. So one thing that you want to notice is when we talk about the word polygon, we'll talk more about this in the geometry videos if you go back and watch those. you have to have a closed figure. So why are we calling this a polygon? Because technically, if you were to extend the line segments from the first bar's point here to the origin, which is 0, 0, and from the last bar here back down to the x-axis, and then also include the x-axis itself, now you've created a nice closed polygon, haven't you? So this is a nice closed figure based on connecting the dots on the bars that we had in the histogram. Okay, so that's all a frequency polygon really is. Okay, so you first start off with your frequency distribution, you make a histogram, and then you play connect the dots until you form a polygon. The next one, though, is a little bit more tedious. Let's talk about it. It's definitely one of the most powerful and popular ways to visualize your data. And that's called a circle graph in our course, but most people, most humans know it as a pie chart, okay? So this is also known as a pie chart. And lots of nice software like Microsoft, for example, Excel and things, they can create these for you. In fact, that's how this one was created, the circle graph here. But if you were creating one on your homework or on a test by hand, or just in real life, you wanted to maybe do your own little budget and you wanted to know what percentage of your paycheck you're spending on each category, a pie chart or a circle graph could be very helpful. So how could you do that quickly? Well, for example, if you have each class represented, let's say by 0 to 10, so you have your frequency distribution maybe at 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, and for the same reasoning that we mentioned earlier, this one really should be 1 to 10 to be completely accurate. In that situation, what you would then want to do, looking just at, for example, the one we used at the beginning, is you would want to take the frequency, which in this case was 4, and divide it by the total number of items. So if you add 4 plus 5 plus 9 plus 8 plus 4, etc., and then you get your percentage, what percentage of items were in this class. That's how you're calculating each of these percentages. So all you're doing is you're taking your frequency divided by the total. Sometimes we call the total n, okay? So we're gonna practice that in a few moments so you can get a better feel for it. 4, in this case it was 30, so 4 divided by 30, 5 divided by 30, 8 divided by 30, 9 divided by 30, 4 divided by 30. And oftentimes what we'll do is we'll actually make a new column here and we'll put a percent here and we'll go ahead and do that calculation side by side so that we can see it clearly. And I'll show you that in a future example. Now the last way that we're going to organize our data in this section is using something called a stem and leaf plot. Now this is not as common in real life, to be honest, but if you are going to take a statistics class, stem and leaf plots come up all the time when you're organizing your data. So when would they be useful? Well, they're useful if you have lots and lots of elements that all start with the same, the same place value. So for example, if we're talking about the 30s, and there's a lot of 31s and 32s and 33s and 34s, what we can do is just start with the stem of that place value, the tens place if you will, the 3, so that's what I'm talking about here, and instead of writing 30, 30, 31, 32, instead of rewriting each of those, once you've written the first number for that place value, in this case for 30 we'd write 3, then all you would need to do is write the ones place for the leaves. So the stem would be 3 representing the 30s, and then the leaf would be 0 representing the ones place, and then another 0 that represents the number 30. The number 1 next to it now represents 31, and the 2 here represents 32. So that's how you read a stem and leaf plot. This would represent 42, 49. The next one would be 58, 58. 67, 67, 69, 78. Notice here that the stem of 8 has no leaves on it. That means that there was no data in that whole place value, basically. There are no 80s represented there. But for the 9 place value, you would have just 1, and that would be 90. Okay, so again, it's a nice visualization if you're trying to point out visually to the audience or to the reader which stem has the most values, the modal class, if you will. Okay, so let's put this to use in our next example if you're ready. If not, go ahead and make sure your notes are sound first. Okay, here we go. Example 2. We're going to create a histogram, a frequency polygon, and a circle graph based on this frequency distribution. Okay, so they've given it to us, and now we just have to use it to make our nice charts. So let's begin looking at what we have here. It looks like it's the one we did earlier, so from your notes you probably already had this one written down from the past. So we were talking about ages 42 to 47, and we had 6 people in that category. Then ages 48 to 53, we had 11. Ages 54 to 59, we had 17. Ages 60 to 65, we had 8. And ages 66 to 71, we had 2. Okay, so these were those presidents again, it looks like. Again, if you add up the total, this Greek capital letter sigma usually means add. You might remember that from like Microsoft Excel or something. When you add up those totals, you should get the sum of 44. That's what sigma stands for in this context. It means sum, the sum total, okay? So the sum here is 44. That's important when we are going to be calculating things like percentages, right? What part of my values belong to each class? So that will be important for the circle graph. So when I think of circle graph, I know I'm going to need percentages. But if I'm just going to start with a histogram and a frequency polygon, that would involve just doing what I did here. Have a y-axis representing our frequency. So we're doing this histogram right now. And then have an x-axis, which represents our class midpoints. Now, sometimes we'll just write classes here, but their representatives are the midpoints. So what were those midpoints once again? We did 42 plus 47. We divided it by 2, and we got 44.5. So for our first class midpoint, we're going to get 44.5. So I'm going to say, let's represent this bar here. 44.5 is this midpoint here. Now, what should the height be? Well, the frequency for that class is a 6. So if I wanted to draw this out, maybe I'll go by 2s, like 2, 4, 6, 8, 10, 12. I could keep going, but I notice, oh yeah, I do have to keep going. I thought it was 11 was my highest. So let's keep going. 12, and then 14, 16, and maybe up here we'll say this is 18. So mine is not perfect because I'm doing it with this marker. It's hard to do. But the idea is they'd be exactly the same distance away each time, right? Same as in a science or math class. Okay, so what we're talking about here is a height of 6. So let's do that. Let's go up to a height of 6 for this bar. That would be right here. And you get to decide ahead of time how thick you want to make your bars. I'm going to make them this thick. So I have to be consistent once I decide to do that. But right in the center, that's where this class midpoint goes. That 44.5 is right there. Then I go to my next bar. My next bar is going to have a height of 11, and it's going to be represented by the midpoint of 48 plus 53 divided by 2. So when you do 48 plus 53 and divide by 2, what do you get? That's right, you should be getting 50.5. Okay, now that should make sense because what was our class width? If you go back to our first example of the presidents, it was 6, wasn't it? There were 6 ages represented in each class, and 6 more than 44.5 is 50.5. So our next midpoint would be 50.5. That's going to be our next midpoint here. So if I go out the same distance here, and then I go up to 11, which is going to be up here somewhere, actually closer to this point if I'm being more consistent here. So this would be my second bar. Let me get a little eraser here. There we go. Okay, so there's my second bar up to 11 at 50.5 for its midpoint. I would then go to my next midpoint, which should be 6 more than 50.5. So this next midpoint representing here is 56.5. And its height should be the highest, shouldn't it? It should be 17. So that would be way up here. If this is 16, 17 would be around here. So we're going to go way up to 17 and then come on down. Again, if I had a ruler, this would look perfect, but don't have that, sorry. Okay. Next up, 60 to 65. What would its class width tell us? Well, the class width of 6 means I add 6 to the previous midpoint. 56.5 plus 6 does in fact give me a midpoint of 62.5. And if you have a nice pencil, you can put them nicely underneath. Okay? And our height that we're going is up to 8, which is right here. Ooh, that's a really ugly line. Let me fix that for you. Okay, a little bit better. Okay, and then finally, for the class 66 to 71, its class width of 6 again adds to the last midpoint of 62.5, giving me 68.5 here for our last one, 68.5, and its height is only at 2, which is right here. Boom. Okay, so we made a little histogram, not too hard to do. Again, if you have a ruler and graph paper, it'll be easier for you. And then finally, to make our frequency polygons, so that would be, let's say in black here, do you remember what we did? That's right, we played connect the dots with a point at the top and in the middle of every single bar, and that's how we make our frequency polygon. You connect those dots with line segments, so nice stiff line segments. Again, a ruler would be very helpful for you. And then what do you do to finish off the polygon? That's right, connect it to the x-axis at the origin here, and wherever this bar ends, oops, that's rough, right there. So there is a nice closed polygon now that represents what's happening with these classes. Okay, the last graph that we have to make is the circle graph, also known as the pie chart. So in order to do that, what did we say we needed? That's right, we need percentages. Okay, so how do we get those percentages? We need the total. There are 44 items in this data set. So we want to know what percentage or what part of the total is represented by each class. So for the first one, to get its percentage, we would do 6 divided by 44, which does reduce to 3 over 22 or 14%. And then we would do 11 divided by 44, which is nice. That's 1/4 or 25%. Then 17 divided by 44, which becomes 39%. And then we did 8 divided by 44. Now that one reduces to 2 out of 11, which becomes 18%. And finally, we do 2 divided by 44, which does reduce to 1 out of 22, or just 4%. Now, what should the sum of your percentages be? What do you think they should add up to? Yeah, that's right, 100. So when you add 14 plus 25 plus 39 plus 18 plus 4, you should in fact get 100%. Okay, so you can verify that. And then if you're doing this by hand, the best thing you could do is have a tool called a compass and a protractor to get the perfect angles, right? So you would say 0.14, for example, times 360 degrees. That would tell you what exact rotation you would want to use in order to create the perfect angle for the circle. But if you're doing a sketch without those tools, like I'm about to do, one thing you can remember is you know how to cut a circle in half, hopefully, right? And you know how to cut it into quarters pretty easily. So I look for any of those easy numbers. For example, the class 48 to 53 has 25%. So what I would do is I'd notice that if I was just looking at a quarter, so if I was looking at a half, for example, I could hopefully cut it in half correctly. That would be half, 50-50. And then if I wanted to, I could then maybe draw a quarter by going up here. So this could be 25%, okay? And that could represent this class, and usually you label it. This is the class 48 to 53. Now notice, unlike the previous graphs, we don't use class midpoints here. We actually label the entire class, 48 to 53. Okay, what's another one that we could do hopefully pretty easily from there? Well, I know that if I had 50%, that would be this entire pie at the bottom, right? Part of the pie. But let's see, the biggest portion I have is 39%, so that's close to 40. So if I'm just estimating, this would be 25, the whole thing would be 50. So I'm going to say maybe up to here, okay? That could be representing the 39%. And that was the class of 54 to 59-year-olds, okay? And then from there, I can say, okay, what would the remainder here be to make up the full 50%? Well, you could do 50 minus 39, right? And you notice that this isn't quite right anymore because that would not fit any of the percentages we have. So at this point, we have to get a little bit sneaky with our drawing, okay? And we could say, okay, well, I know that the full 25% would have been here, but I only have, let's say, 14 and 4, which is 18%. So that would be a little bit less than that full 25% when you combine them together. So I could make maybe this part here, we could make this part the little tiny 4%, and this part could be the 14%. So 4% was 66 to 71, and 14% was 42 to 47-year-olds. And that leaves us with this 18%, which is a little bit bigger than what we have for 14%, so that kind of makes sense in our picture here. So that would be our 60 to 65-year-olds. So we label all of our pieces, and we just did a basic circle graph. Definitely better to use technology and to do it perfectly, or use tools by hand to do it perfectly that we mentioned. But if you're trying to do a basic one, that's how you could do it by hand. All right, we have one more example. Let's head over to it when you're ready. This one says, could you construct a stem and leaf plot for the ages of those 44 presidents that we talked about? Okay, so this is the same data, no need to rewrite it. It's already pre-sorted, which is very helpful. And all we're asking you to do now is construct a stem and leaf plot. So it's that last type of visualization that we mentioned earlier in the video. So what did we need to do? That's right, we needed to have a stem and we needed to have leaves. In fact, I think I might scoot over a little more to the left on your screen so we have more space. Let's see if I can do that better. Yep, you can see it. So here's our stem, and then here's our leaves. Some people write leaves, other people write leaf. That's your prerogative. Okay, so the first thing I notice is that the smallest stem that I will need is a 4, right? So that's my smallest stem. My next stem would be a 5, representing the 50s, followed by a 6. You can see that the need for the 6 stem is right here. And if I had a president who was just a little bit older, I would need another stem of 7. But since I don't, I could stop there. And now it's simply a matter of writing down everything I see. So it's very tedious, but not difficult at all, as long as you've sorted things correctly and you can keep track of everything you do. So for example, in the stem of 4, the following leaves we would have would be 2, that represents age 42, 3, that represents age 43. Notice I'm not putting a comma after each one. Tradition is you just put the numbers very close together. It's hard to see, but that's what we do. Followed by 6, another 6. We do repeat the items as many times as we need to. Another 7, another 7. So there's 2 7s. There's an 8, and then there are 2 9s, representing the ages of 49 twice. And I usually like to add up how many I've done each time. So in that case, I notice here that I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I've accounted for 9 items. Now this is not part of the stem and leaf plot, but I'm just keeping track for myself because I want to make sure I have 44 in the end, okay? Then I go to my next stem of 5, and I do the same thing, but this one's a lot more tedious. We have 2 50s, so I need a 0 and a 0. We have 1, 2, 3, 4 51-year-olds, so there's 4 1s right in a row. We have 1, 2 52-year-olds, so we're going to write 2 and 2. We have 1, 2, 3, 4, 5, so 5 54-year-olds. So we're going to put 5 4s, 1, 2, 3, 4, and 5 right next to each other. How many 55-year-olds did we have? 1, 2, 3, 4. So we need to write 5 4 times. 1, 2, 3, and 4. Okay? 56-year-olds, we have 1, 2, 3 of them, so 6, 6, 6. All right? 57-year-olds, 1, 2, 3, and 4, so 7, 7, 7, 7. 58-year-old, just 1 time, so an 8. And that's the end of the 5 stem, representing all 50-year-olds that we had as presidents on Inauguration Day. And again, when you add that up, I believe I got 20, look at my notes here. Yes, 25. Check me out though, because I could have easily miscounted that. Okay. When you get to your last one, simply, again, keeping track of what we've done, let's go to the 6th stem. We have 1 60-year-old, so we write a 0. We have 1, 2, 3 61-year-olds, so we have 1, 2, 3 1s. We have 1 62-year-old, so we write 1, 2. We have 1, 2 64-year-olds, so we write 2 4s. We have 1 65-year-old, so we write 1 5. 1 68-year-old, right? 1 8, and 1 69-year-old, 1 9. And I believe there are 10 items there. When you add up 25, 10, and 9, do you get 44? If so, you've talked about all of your data. And again, you can mark off as you go so you can keep track as well. So it's one of the easiest ones to use, and it's also very nice to visualize where most of our presidents' ages were. Most presidents were in the 50s on Inauguration Day. That might not be the case anymore. All right, so what I'd like you to do is to practice all of the different ways that we talked about in this video to construct a visual graph, whether it's a histogram, whether it's a frequency polygon from your histogram, or a circle graph. The very first step, sorting, and then create that frequency distribution. Of course, the stem and leaf plot, you don't need to do any of that work. Just sort and go to town with your stems and your leaves. If you have any questions, please reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.